So I took Gemini and I asked it to break down the article so that I could completely understand it. So this paper invents the field of computer science since you're looking at through your C++. So part 1, the hardware specification. In sections 1 and 2, it defined the tape as infinite one-dimensional RAM, which is how we see RAM in computers. So that makes sense. The head can only scan one square at a time, which also makes sense, as in it can only do one operation or read one thing at a time. The state has a finite number of states, and on the move, it has a clock cycle and can only do one thing based off of the state. So that all makes sense. Part 2, we went over this in the first video with this basic script doing 0, 1, 0, 1 in the F squares and having E squares in between each one of them. So this makes sense as well. The skeleton tables were confusing the first time I read about it. So it says Turing realizes that writing state tables by hand is tedious. So he introduces skeleton tables, which are essentially macros or functions. And the example is the function f, or the skeleton table of f. It looks for the function a, or the symbol a, and transitions to state C if it finds it, and B if it doesn't find it. So that clears up this. It's like this makes sense. If it's B, goes to C, C goes to E, which goes to F, which goes to B. So it keeps doing that cycle, right? And then when he's allowed to do more than one operation, he can simplify it, which makes sense as well. And then let's find the functions. So here's the functions. So F will call F itself if it's not E. And then otherwise it'll call F1, and F1 will then do this. So this makes sense as well, or makes more sense. Then part 3 is he takes the letters which like define an action such as moving left or right, and then he maps numbers to those letters. So he basically says that every script that you can write can be converted into a number, an executable binary. And this is very helpful for the idea of the universal computing machine, which is U. And this machine can take any of these numbers and walk through them, one number by one at a time, until it does this script. So the universal machine is an interpreter. So that's good to know. And then having a universal machine proves that, well, wait. Then he defines the halting problem, circle free or circular. Well, yeah, look. So then he proves that you can't solve that. So then he proves then he defines, all right, restart. So in part 5, he pivots to the N-Shindun's problem to determine whether a program will finish or keep running. And then he defines circle free or circular. And his proof is that if you have machine H that will either return 1 or 0 if the program that's put into it will end, and then you put H into H, it's a paradox, if that makes sense. And then in section 9, he argues that his machine covers all natural computation, and then proves that pi and e are computable by his machine, which doesn't really make sense to me, since those keep going on forever. Where is it? Right here. So he proves that you can find e by just adding up all of the subparts of it. And then section 11, he proves that since no machine can decide if another machine prints 0, math is undecidable, or that there's no solution, it seems.